Tessellations. In this video, we will be exploring tessellations. The questions that we will answer in this video are: what is a tessellation? Which regular polygons can be used on their own to create a tessellation? And what are some examples of tessellations in the world around us? What is a tessellation? A tessellation is a pattern or arrangement of polygons so that the polygons do not overlap and there are no spaces in between them. Now this is done in 2 dimensions, so that means a plane or 2-dimensional area is being completely covered with no overlaps. If you look at the picture on the right, you can see that various parallelograms fit together without overlapping to cover a 2-dimensional space. This is an example of a tessellation. Tessellations have been used in design for a long time. Look at this example from 4000 BC. That's over 6,000 years ago. See how the colored patterns use tessellations? The equilateral triangles used to cover the second column, and the parallelograms used in the one to the right of it. The tessellation using the equilateral triangles is a special type of tessellation, since it's using a single regular shape. This is called a regular tessellation. A regular tessellation is a tessellation made using just one type of regular polygon. Since the graphic shown here is using only regular triangles, that's considered a regular tessellation. Remember, a regular polygon is a polygon with all sides the same length and all interior angles congruent. So, for example, a square is regular since all sides of the square are the same length and each interior angle is 90 degrees. Now, looking at these regular polygons, which can be used to create a regular tessellation. See how a regular hexagon can cover a 2-dimensional space without any spaces or any overlapping. So, a regular hexagon can tessellate by itself. A regular octagon cannot cover a 2-dimensional plane without either leaving spaces or overlapping. So a regular octagon does not tessellate by itself. However, you will notice that if you add in a square, you could create a tessellation using 2 regular polygons. This, however, would be called a semi-regular tessellation and not a regular tessellation. Now, you may ask yourself, why do some regular shapes tessellate and not others? Well, it's really about angles. All the corners of the shape come together at a point called a vertex. See how around that vertex makes 360 degrees since it's a circle? The interior angles of a hexagon are 120. So 120 plus 120 plus 120 will give you exactly 360 degrees. However, with a regular octagon, the interior angles are 135, so it just doesn't fit, since 135 plus 135 plus 135 equals 405. 405 is greater than 360, so the regular octagon cannot be tessellated by itself. Now let's look at the other regular polygons. Which of those can tessellate? Well, it's really about them being able to make 360 exactly. So 60 degrees does divide evenly into 360, so that one can tessellate. The square does divide evenly 90 degrees into 360, so that one can tessellate. 108 does not divide evenly to 360. 120 for the hexagon does divide evenly. We saw that earlier. So that one works. 128.57 does not divide evenly into 360, so it cannot tessellate. For an octagon, we already saw it cannot divide evenly, so it cannot tessellate. So we're seeing here that only 3 regular polygons can tessellate: the triangle, the square, and the hexagon. You might say, how can you know for sure that none of the higher number side regular polygons will tessellate? Well, look at those interior angle measurements. They keep getting larger and larger. Since they're getting larger and larger, we can safely say that none of the ones with higher angles will tessellate, since 135 was already too large to tessellate. Tessellations are sometimes called tilings, which makes sense since most tiles are examples of tessellations. Think of examples of tiles in your own home or school. What kind of tessellations do they show? I bet a lot of you have examples of hexagons or squares. Since what we just saw about regular tessellations was that only triangles, squares, and regular hexagons can make a regular tessellation, it's not surprising that hexagons and squares are so common in tiling. So, what have we learned about tessellations? Well, a tessellation is an arrangement of polygons to cover an area with no gaps, no shapes overlapping. We also saw which polygons can be used to create a regular tessellation, that the use of tessellations dates back as early as 4000 BC. Tessellations can't have gaps. Shapes in a tessellation cannot overlap. Here are some examples and non-examples of tessellations. Thanks for watching.